no measurement, no matter how carefully made, is accurate. All measurements are approximate. So we're going to look at approximation, which entails percentage error and bounds. Now, let's look at this. The length of a pole is measured as 5 meters to the nearest meter. What does this thing mean? How do we know the error? Now, when they say to the nearest meter, they mean the error is to 1 meter. This is saying that if you have a flagpole and you've measured it to be 5 meters, it means the difference from the lowest point it can give you to the highest point it can get to is 1 meter. Say highest point it can get to is 1 meter, meaning that from the lower point to the upper point it can get to is 1 meter. Here, the lower point it can get to is called the lower bound. The highest point it can get to is called the upper bound. Now write this in full. The lower bound, which is LB, and the upper bound is 1 meter. Meaning from this value we've gotten to the lower bound, the lowest point it can get to that can be approximated to give you 5 is this. This is divided by 2. You subtract 0.5 here and you also add 0.5 here. That's what it's saying. Or in essence, we can write, okay, this is upper bound. We can say this is plus or minus 0.5. We're still saying the same thing. Still saying the same thing. Just to put a clause to it, if you approximate 4.5 here, 4.5, it gives you 5. Here, if you approximate 5.45 or 49, it gives you 5. The reason why we make it 5.5, sorry, is because it is so tiny, the difference is so little that we can actually overlook the remaining. So we make it this. But it's actually 5.49 and this is 4.50, such that from 4.5 to 5.9, the difference is to the nearest meter, nearest 1 meter. Now, to find the percentage error in any instrument is we first get the error. Getting the error, we first get the error. The error is normally the actual value minus the error value. The error value or error value, if the error value is bigger, error value minus the actual value. Actual value. This is how to get the error. This is how to get the error. Now, having said this, remember, actual value minus error value is saying that the actual value AV is greater than the error value when you use this. And when you use this is when the actual value is less than the error value. That's how to get the error. How to get the error. Now, to get the percentage error, we have the error over the actual value or measurement. As we know, there is no actual value that is correct. Based on the measurement or the what we what we what we are taking to be our actual value is an assumed value that we believe based on the level of or the degree of accuracy that is what the measured parameter is times 100 over 1 or 100%. So this is how to get percentage error. This is how to get percentage error. Let's take an example. Now let's look at this question. It says a stick of length 1.75 meters was measured by a boy as 1.80 meters. Find the percentage error in his measurement. Percentage error in his measurement. Now, to get the percentage error, simply we put this. We know the actual value is 1.75 meters and the error value as 1.80 meters. So because to get the error now will be the error value is greater, so it's error value minus actual value, which gives us 1.80 minus 1.75, which is 0.05 meters. That's the error. So to get the percentage error as we know it is percentage error is equals to the error over the actual value 1.75 times 100%, 100 over 1. This is what it is. This is what it is. So with our calculator, we'll have it to be 2.67. Wow. Okay. Two whole numbers, 6 over 7%. So this is his error. The error is 2.2 whole number 6 over 7%. 2 whole number 6 over 7%. Okay, look at this question, an IGCSE question on bounds now. Violet and Wilfred recorded their times to run 200 meters, correct to the nearest second. Violet took 36 seconds and Wilfred took 39 seconds. Work out the upper bound of the difference between their times. It's an IGCSE question. Now, let's see. We're going to solve it now to the nearest second. Now, these are their times in seconds, both for the lower bound for Violet and Wilfred. So, this is for Violet. This is for Violet. And this is for Wilfred. we're asked to get the upper bound of the difference, meaning the largest difference. For us to get the largest difference will be for Wilfred, we'll take the upper bound for Wilfred minus, we're going to take the lower bound for Violet. Only then can you get a large, very large number. Else, you will not get the largest number. Now, for the records, when you are asked to get the upper bound of their difference, you are going for the first value, you are going to take the upper bound, and the other value, you are going to take the lower bound. The largest value or the upper bound of their difference, and also the upper bound of their quotient, when you are to get the upper bound of the quotient or the difference. When I say difference, I mean subtraction. When I say quotient, I mean division. For quotient, difference or quotient, for difference, let me put it here, for difference or quotient, we're going to use the upper bound of the first value and the lower bound of the second value. Upper bound of the first value and the lower bound of the second value for both difference and quotient. Difference and quotient. But when they say looking for the addition or the sum or the multiple, we use both upper bound, that's upper bound, and upper bound. That's what we're looking for. Upper bound of this, as this question has said. Upper bound. Let me repeat myself. We're looking for the upper bound of the difference. Upper bound. When it's upper bound, you start with upper bound for difference and quotient. You start with upper bound. Also for sum and multiple, you start with upper bound. The difference is this. When it is difference or quotient, the last bound you are going to take is the lower bound. But for sum or multiple, if they're looking for the upper bound, you are going to use the upper bound of both of them. But they say the upper bound, when you have difference and quotient, you are going to use the upper bound of the first value and the lower bound of the second value for upper bound of the difference or upper bound of anything. But when they say lower bound of anything, you are going to reverse this. Lower bound, you're going to use lower bound, then upper bound, then here lower bound and lower bound. I want you to look at it again, play this video again and again to understand what I just explained. Now I'm going to actually have more than 3 examples to buttress this point. Now for this, we will have the upper bound of Wilfred, because she has a larger number, which is this 39.5 minus, remember the difference, the final difference, lower bound of Violet, which is what? 35.5, which gives us 4 seconds. 4 seconds, and this is the answer. That is the answer. Let's take another example so we can understand this better. Now let's see this question. A dressmaker measures the length of a fabric as 600 meters. 600 meters, correct to the nearest 5 meters. He cuts this into dress lengths of 9 meters, correct to the nearest meter. Calculate the largest number of complete dress lengths he could cut. He could cut. Now let's look at it. Largest number. Largest number. So they mean upper bound. Largest number. So we mean upper bound. Okay? Okay. So let's see for 600 meters. 600 meters. The The upper bound will be plus 5 over 2, which will give us 602.5 meters. This is the upper bound. This is the upper bound of the fabric is about cutting. So, because we're looking at a quotient here, we're going to divide. So we'll take the lower bound of this. The lower bound will be 9 meters. This will give us to the nearest meter. So meter is 1 over 2. Sorry, minus 1 over 2. So the lower bound will be 8.5 meters. I just changed this to decimal, which is 0.5. 9 minus 0.5 will give us that. I changed this one to decimal, that's 2.5. 600 plus 2.5 is 602.5. That's how I've gotten it. So I've gotten the upper bound of this and the lower bound of this. Why? For me to get the number of complete dress lengths he could cut, I will have to divide, meaning divide 600 by 9. Because I'm dividing, I'm going to look at the upper bound of the first one because I need largest number. Upper bound of the first one and the lower bound of the second one. But if I was asked to get the lowest number, I will use the lower bound for the first one and I will use the upper bound for the second one. Let me take it again. If I was asked to get the lowest number, I will use the lower bound of the first one and the upper bound of the second one. But since I was asked to get the largest number, I have used the upper bound because larger number. I will use the upper bound of the first one and the lower bound of the second one. Now, let's see what it will give us. So, this will give us the largest number will give us the upper bound will give us upper bound over lower bound of the second one. So, or largest number. So we have upper bound is 602.5 over lower bound, which is 8.5. So we will have 70.88, since they say the largest number of complete dress lengths. Complete. So we take the floor value, which is what? 70 dress lengths. So this is our answer. That is our answer. 70 dress lengths. Let's take another example. This is another example, though an easier one. So the question says the area of a square is 42.5 centimeters square. Correct to the nearest 0.5 centimeters square. Calculate the lower bound of the length of the side of the square. Sorry, side of the square. The side of the square. Okay. Now let's see this. This is the square. Let's just see this. If this is the area, such that this is 42.5. It means the upper, this is the lower bound, sorry, the lower bound, and this is the upper bound. The low, and it is 0.5. If you divide 0.5 into 2, you have 0.25 and 0.25. So we were asked to get the lower bound. The lower bound. So the lower bound, let's see the lower bound. We're going to use lower bound. So this is 42.5 minus 0.25, which will give us 42.25. The upper bound here will give us 42.5 plus 0.25, which will give us 42.75. We do not need this, but we need this. We need that. So, since we have it, we'll just look for the square root of that number. So, we look at use the lower bound. So, because it's a square, to get the sides, is length, the area is normally L square. So if area is this, 42.25 equal to L square. So to get L will be square root of 42.25. So L will have 6.5 cm. That is our answer. That is our answer. So let's try this. I'll drop a question so we can look at it together. Or you do that and drop your answer in the comment section. This is the question. The space allowed for each tent in a campsite is a rectangle, measuring 8 meters by 6 meters, each correct to the nearest meter. Calculate the upper bound for the area of the space allowed for each tent. An IGCSE question. Kindly solve and put your answer in the comment section. Achia.